Hey everybody, in this episode I want to talk about samplers and coordinates. So with samplers we can achieve some effects like this and much more. So let's see what we are talking about. The setup is the same as in the previous tutorials. The only difference is that I added a background just for aesthetic reasons that makes this kind of radial gradient. So let's create a JIT.GEN object and connect it with the output of the unpack and its outlet with the input of the GGL mesh, and we see that our sphere appears since we are just passing the coordinates to the GGL mesh. If we enter the JIT.GEN object, we can delete the input2 and the plus operator, and I want to introduce you to an object that is specific of the JIT.GEN environment. This object is called norm. If we click with Alt keys or Option key and click on this object, we get some help popping up. So it says normalized coordinates of input matrix 0 to 1. And if you recall, on the first tutorial, I told you that the JIT.GEN object works on every single cell of the matrix that comes in parallel. And the norm object produces a normalized coordinate, so in the range 0 to 1, for every single cell of the matrix. So if the matrix is a two-dimensional matrix, as in this case, the norm object will produce x and y coordinates in the range 0 to 1. So if we create a back object with 3 inputs, so depending on the number of values that we input here, we get a different number of inputs. If we input 3 numbers, then we get 3 inputs. Since the matrix that comes in is a 3-plane matrix, we can have just 3 planes in the output. So we can never have more than the number of planes of the matrix that comes in. So if we connect this back with outlet and then proceed to switch the x coordinate of the coordinates and then also the y coordinate of the normalized coordinates, and we attach this to the y position, and we get a square that goes from 0 to 1 on the x-axis and from 0 to 1 on the y-axis. So these are normalized coordinates. If we give the GTL mesh the attribute polymode 1, there's too many points, so we can't even see the grid, but if we diminish the number of dimensions of this matrix here, we can see that it formed a grid. So let's go back to the original dimensions. Okay, so this is what's inside normalized coordinates. Let's see a second object that provides us with coordinates. It's called S-norm. And the S-norm object, it's exactly like the norm object, but instead the range of the coordinates is from -1 to 1, so signant coordinates. So if we switch its components, x and y, then attach this to this vector, we have now a grid that goes from -1 to 1 on every direction. So -1 on the x, 1 on the x, -1 on the y, and 1 on the y. Okay, then we have another object that gives us coordinates, and this object is called cell. So the cell object, cell coordinates of input matrix 0 to dim -1. So this gives us the integer coordinates of the cell that comes in. So since I have a matrix that is a 200 by 200 matrix coming in, this object will give me the coordinates 0, 1, 2, 3, 4 until 199. So in order to get a grid from this object, we have to divide this, for example, by 200 and 200. Now look at that. Most of the operators in JIT.GEN take vectors arguments. So this object is dividing incoming vector, because this is a vector, is a two-dimensional vector that comes in, is dividing this object for a vector 200 by 200. So it's performing vector division here, which is exactly like if we divided the single components for this number. So if we do that, then switch also those components, then we get the exact same result as the normalized coordinates. So let me x and y cell index the range 0 to dim -1. This is what comes out of the cell object. Okay, now there is a built-in variable inside JIT.GEN that gives us the dimensions of the incoming matrix, and it's a vector also that contains as many values as the dimensions of the matrix. So if it's called dim. Dim is a vector now that contains two numbers, 200 and 200. So if I divide this by dim, I get normalized coordinates in the range 0 to 1. It's like divided by the dimensions of the matrix, but this will automatically give us the dimensions of the matrix. So matrix dimensions. Okay, so this is what we have for coordinates inside JIT.GEN to generate coordinates, and this will come pretty handy in the future where we will want to generate shapes just from starting from coordinates. But now I want to introduce you to another object, the sampler object. So let's see this object. It's called sample, and this object takes, let's take the input one, takes the output of an input of the JIT.GEN object, so it must be directly from the input one in its left input, and then on the right input it takes a set of coordinates. So by default it takes coordinates from 0 to 1 to cover the whole matrix that comes in. So this will get us the cell of the matrix relative to the coordinates that the JIT.GEN object is currently working on. So if we attach it coordinates from 0 to 1, it will give us the whole matrix that comes in. So for every cell, I'm sampling this. We are sampling this cell according to input coordinates. For example, I can say, let's switch x and y for that, and I can say, give me just, let's create a greater than object. So let's say greater than 0.5. So since its coordinates in the x value goes from 0 to 1, 0.5 will be half of the x. Now let's create a gate object. Let's say when this is true, let's pass the x. And then let's create a vector 2 to put together the coordinates one more time. So now we have reconstructed this vector, but now we have just half of the original cells of the matrix. So if we do the same also for the y dimension, this is what we get, like a quarter of the whole sphere. But you can see that all the vertices cutted converge to 0, and let's see with poly mode. And that's because when the gate is closed, by default, from output 1, it will output a vector 0, 0, 0, so the center of the coordinates of the sphere here. But one thing that I want that it's clear is that these are not coordinates of these are not x and y coordinate of the sphere. These are x and y coordinates of the matrix in which the sphere is contained. So let's make a paint. So this is the matrix in which our shape is contained, the matrix that we get out from the JIT unpack object. This is our matrix, it's 2 dimensionals and 3 planes. So these are other 2 planes here. And what we are doing with the coordinates and the sampler object is that, for example, when we say that the coordinates must be greater of 0.5, we are just taking half of the original matrix. And when we say that the y coordinates also have to be greater than 0.5, then we are just taking this other piece of matrix. So, and this is of course valid for all the planes. So we are just taking this small portion of the matrix that comes out from the JIT unpack, and this is actually a quarter of the sphere. But these are not the coordinates of the sphere itself, the one that we are filtering, but the coordinates of the matrix in which the sphere is contained. Okay, so let's see a couple of tricks that we can achieve with the sample object and coordinates. So let's create a param called time. So I have a clocker object here. It's like the one from the previous tutorials. And let's take the cosine of time. Let's multiply this cosine. Now let's actually add 1 to this cosine, so it goes from 0 to 2. And now let's multiply by 0.5, so it goes from 0 to 1. And now let's create a norm object, so we get normalized coordinates. And then let's create a fold object So it will fold these coordinates, so the fold operator works with vectors also. So for both the x and y components of the norm object, it will fold between 0 and the number that comes out from this operator here that goes from 0 to 1. So we get this kind of effect. The sphere gets slowly sampled and created. We can also try various operators, like the wrap operator that wraps the input between 0 and 1. So the effect is pretty the same, but we get the full volume of the shape. Then we can try also with a clip operator that will clip between 0 and this value. So we get this flat splat thing. Okay, so there are a couple of things that we can do with with a sample object. Now, just for sake of completeness, I want to show you another object called sample pix that is exactly like the sample object, but instead of getting normalized coordinates between 0 and 1, so let's take the input one. It takes cell coordinates, so between 0 and the dimensions of the matrix -1, so we can use the cell object to sample our matrix. We get a little artifact here. Then let's see, there is another sampler. So the samplers are still not over, there are a couple more and are nearest. So the sample operator makes interpolation between the values of the cells. If it gets a coordinates that is exactly between the values of two cells, it makes interpolation between these values, while nearest sample a matrix at a given coordinate, so without interpolation. So it still takes normalized coordinates. And now we have also another one called nearest pix that doesn't perform interpolation and takes cell coordinates. Oh, and this, differently from sample pix, doesn't give us any artifact. So actually, when working with three-dimensional shapes, we want to work mostly with the nearest pix to sample these shapes. So that was it for this tutorial. I hope everything is clear. If there are some questions, please ask me, and let's see you in the next one. Ciao.